So, good evening. Once again, welcome back to the interactive preparation session. So, to begin with, last session we stopped at a point of histogram analysis. What does a histogram represent? So, today we'll start with the next level of questions. The continuation would we would complete the rest of the statistical analysis part. So, an analysis that can be applied to one variable at a time to plot or analyze, right, is called as what kind of analysis? Right? In analysis, what you have applied to one variable. So when I say one variable, right, at a time for plotting purpose or for analyzing purpose is called as what type of analysis? So when I say one variable, we have various plots, right? When you take histogram, if you take bar plot, if you take bar chart, sorry, bar plot or bar chart, both mean the same, box plot, right? All these, what you are doing, as we have discussed already. So it is something which you can only have one variable at a time. It's only possible for one variable at a time. So either you have 10 variables also, right? That would only one variable is what you consider for analysis. So what is that analysis called as? You name it as univariate analysis, right? It is nothing but univariate analysis. So next, to begin with, we are talking about EDA. We started with the data types, then measurement levels, then data cleansing, right? So as a part of this, why do you think that, right, data cleansing is very important? What makes it? What is a vital role here of data cleansing part? So next question would be, I would say, why data cleansing, we can say, plays an important role in analysis. Why it is so important for us? So when you talk about, so we all know that most of the time here only goes in preparing your data, right? It is only like preparing the data for model building. So as a part of this data cleansing, because you are not getting data from one source, cleansing the data is from multiple sources, right? To transform it to a format, we require data analytics persons or data analysts are required, or you require data scientists, right? So what happens? These people would work, because as the number of data sources are increasing, the time taken for the data to clean it also will increase exponentially. This would happen, right? Exponential increase would happen here due to the number of sources, and also the volume of the data which is being generated in these sources is also changing. So that's why we always say that 80% of the time just cleansing the data, right, makes it a very critical part of our analysis. The task, it's a big task for us, because we are doing imputation, we are checking the outliers, right? We check whether any dummy variable creation is required or not. Right? What are the things we can do here? You do dummy variable creation. Right? You will handle the duplicates. We'll go for imputation techniques, where if data is missing, right? Whether you want to make your data unitless, right? Where you have to do either standardization or normalization, right? So these are a few techniques which will take lot of time to analyze and to make them perfect for model building, right? To make it perfect for model building. So when we talk about data cleansing, good, we have understood that we have typecasting, we have imputation technique, we have outlier treatments, right? All these are part of your data cleansing. Right. So when you talk about the next, right, let us see something about probability. So what is probability? First of all, what is probability all about? This is a word, which is a very scary thing and people get scared of this, right? They assume that, okay, probability means something tough. What is a simple, the formula or any explanation would be here. So when you talk about the probability, we just say that simple, right? The number of interested events, right? Number of interested events by total number of outcomes. So when we say interested events, this would be desired event, right? Desired event by total value, right? So anytime when you talk about, always we say that yes, when you have head or tails, right? We could have a probability. What is the chance that this is a head this time? If you just toss a coin, or what is the chance it could be a tail, right? So suppose we just if you take any real time, not real time, like normal example here. Suppose I say that you have two of the friends, okay? We would take two boys, right? They just came to the exam hall late. So they thought that, okay, some paper leak could happen, some questions would be leaked. So when the professor will ask him, definitely they'll question, right? Why are you late? So what happened? They told that, the back tire punctured. That's why we are late. So that was the reason, sir, for being late. That is an answer given by the boys. So the professor allowed them to write an exam. So they were given what? Only one question. And that one question was for 100 marks, friends. Right? So the question is, which tire, right, got punctured? That was the question. Which tire? On a jovial note, okay, don't deep dive into that. Which tire got punctured? Right? So my question would be now, what is the probability that the both of the students, both the boys, have mentioned the same tire? Right? The probability would differ, right? If it is the same tire or if it is a different tire, we don't know. What is the probability that it is the same tire? Because both are friends, we don't know, because we are not getting into all those details. We are just checking whether the probability that both students have whatever they have mentioned, right, are they talking about the same tire or not? So probability is nothing but simply your desired or your interested events by total number of outcomes possible, right? If you take head or tail, what are the possibilities? Half, right? 2. Desired is either head or tail. This is my desired. By 2 is the possible outcomes. This is 1 and this is 2, right? So for any, let me write down the next question. For any impossible event, if you talk about, okay, for any impossible event, right, what is the probability? Right, when you talk about for an impossible event, what is the probability? Yeah, tell me. So if you talk about the impossible events, right, the probability, if the probability of an event for anything, right, if you say that the probability of an event is 0, right, we say that it is an impossible event. We say that it is an impossible event, right? Now, why not we talk about even the conditional probability, right? Why don't we talk even about the conditional probability, right? How would you explain if I say what is conditional probability? Yeah, what is conditional probability? Okay. Yeah. What is conditional probability here? Right? So when you talk about condition, right, with respect to probability, right? So how do you explain that? It's just like, let us take a small example here to understand what is it. When I say I have 52 cards, right? So if I ask you to pick one card, right? Pick one card. So what is the probability that you would end up getting a diamond card here? Dependency, exactly. Right? Diamond card here. Exactly, Kiran. Right? So it's a diamond card. You will get a probability as 13 by 52. Now the second scenario comes here. What is the probability of getting a diamond card again? This is my event A. Right? What is the probability that you get again a diamond card? Right? What's the probability that it would be again a diamond card here? Right? First thing would be here, yes. If I not mention that the first card is replaced or not. If it is replaced, I would get again the same answer. What if I'm not replacing that card? If I'm not replacing, I would get 12 by 51. Is this correct? Maybe, right? We don't know. We don't have, we are clueless of what is the first event. First time, maybe you have got some heart-shaped card, right? So if the first is a heart-shaped card, then the probability of the second pick would again give a different answer for you. Right? This all comes under your conditional probability, where the second event output is dependent on your first event. Right? When your second event's output is dependent on your first event, then that is called as conditional probability. Right? Can someone put another example here? Rajkumar says dependency. Rakesh says probability. Yes, exactly, Kiran. You are correct. All are correct. So anyway, we can take one example of like elections, right? If you just say the same person, the same contender, right? He is elected for the second time also, right? He's elected second time. How he is elected second time? Based on the promises, what he had done, right? Whatever he has done in when he was campaigning, right? Maybe he has promised free Wi-Fi or free food, something, etc., etc. That could be an example for conditional probability, right? So yeah, nowadays, people, many younger generation guys, they just have they think more stress, right? What happens? They are facing many issues, headache, some sinus problem, something, right? Though they are doing so lot of yoga and all that. So conditions that they are doing yoga, still they are feeling so much stressed. That could be one more example, friends. So then what is this probability distribution all about then? When you have come to probability, what is probability distribution? Yeah. How do you explain probability distribution? See, whenever you have bunch of outcomes, right, in which one of them has more chances, right? So what are those chances here? So we always look at the share, right? The probability share on this outputs, whatever outputs you are considering. Distribution of the data, exactly. So suppose, if you take any, because every time we are thinking about COVID positive or negative, like if you have just gone for any test, diagnostic test, whether a person is a cancerous patient or non-cancerous patient. So the possibility is only two, either it is positive or either it is negative. So what is a chance to have a positive case or what is a chance to have a negative case? Right? There will be some chance, right? How much chance is there to it to be a positive or it to be a negative? So this is, you are doing one experiment. So when we conduct the experiment, we would definitely have something called as outcomes. So every outcome would have some chance. Every outcome would have some or the other chance, would definitely some chance would be there here. Right? So each possible outcome would have some chance. This chance is probability. And understanding the chance for each probability is a probability distribution. So we can have continuous probability distribution. We can have discrete probability distribution also. For example, if you just take the pattern, like salary hikes based on the experience, right? It's talking about the salary. Then I say that it is continuous distribution, right? It would be what type of skewness? It would be left skew, right? So if you say that, like an example where, the probability of getting a new job based on the experience, getting a new job based on the experience would be again continuous distribution, right? And that would also be opposite to left, that would be right skew. Yes, Kiran, continuous distribution, right? So it could be, now someone can give me for discrete. Any example for discrete probability distribution? Yes, friends. Yeah. Okay. No one. So when you talk about discrete, it is nothing but, when you roll a die, right? You can also say that it is a uniform distribution also. Right? When you roll a die, what is the chance that you get 1? What is the chance that you get 2? What is the chance you get 3? What is the chance you get 4 or 5 or 6? Right? This would be an example for every time the answer is same, right? 1 by 6, right? It is 1 by 6. iPad sales per day, 1, 2, exactly 1 by 6, right? Every time it is so. You can also call this type of distribution as, example could be discrete, and also this is uniform distribution, right? It is uniform distribution. Now, this is good enough. 3 things about probability, right? Now, what is this inferential statistics all about? Yeah, inferential statistics, or I would rather ask sampling funnel. Yes, friends. Sampling funnel. What is sampling funnel or inferential statistics? Simple random sampling is inferential statistics? Not really, Rajkumar. See, whenever you're talking about sampling funnel, take data from samples and make generalizations about a population. Exactly. Right? So let me explain. It is an entire process where you are deriving results, right? Where you are deriving results from the population. So from the population, we are taking subsets of the data, right? You have a very big population. This is the entire data, right? Now people around in the whole country or whole world, if you take, that will become your population. From that, you are picking subset of data. You are performing analysis, right? So whatever inferences you are getting here, right? You try to get some insights out of it. So whatever results you get, what do? You generalize it to population. Right? The subset of population would be sampling. So the results what you get on sample is called what? Whatever your results you are getting here, I have highlighted, right? From the sample, what you call them as? Inference is what you get on a sample data. I mentioned inferences. You call it as statistics. Right? Whatever you're working on data, you call them as statistics. Right? Whenever you're working on population, you call them as population parameters. Right? You call them as population parameters, you call them as statistics. Hence, we are calling it as inferential statistics. It's just like, we are all eagerly waiting for vaccine, right? So you are researching and finding COVID-19 vaccine, virus vaccine. It is tested on sample, right? Only on sample of patients. If it cures perfectly, if it works, what they tell? They generalize it and they say one statement that we found a vaccine for the entire population. It is working very fine, good enough. Everything is satisfied, right? So this is your sampling funnel, inferential statistics. In between, you have many things. What is this? Why you are calling it as a funnel here? We'll deep dive into everything. Sampling frame. Then you are applying. Someone just dropped SRS. Right? Then it is sample. Right? So let's discuss few things about this. Now, when we just understood that what is inferential statistics, then what is this descriptive statistics? Is there any difference between them? Descriptive statistics and inferential statistics, how do you differentiate? Yes, friends? How do you differentiate descriptive statistics and inferential statistics? Yes. Yeah. What does descriptive statistics do? Inferential statistics, just now we understood. We are attempting to make some inferences, randomly selected. What randomly selected? Inferential statistic is randomly selected. It's our choice, right? You go for any type of sampling technique. So inferential descriptive statistics will summarize the characteristics of the data. Exactly. It would explain you, right? Describe, like descriptive analytics, what we are doing. It will explain what happened actually. You are able to understand, you are giving an attempt to understand, to describe what the data is holding, what insights you can guess, what happened actually. Right? But what about this inferential statistics? We are making inferences, right? We are just saying that whatever inferences are made, based on the data, you are trying to get something, but you are generalizing it to the population. You are picking them, right? This entire process is what you are picking a sample to get some inferences. But descriptive statistics is describing, it is summarizing the data. Right? Description, whatever the data you have, it is doing that. Okay, then we have left with this sampling frame and SRS. Now, what is a sampling frame? Sampling frame, yeah. the second thing in our funnel. I have not made it as a funnel shape, but still. Sampling frame is all about yes. What is the sampling frame all about? So whenever you are working, right, with population, what would we do? Yes, we are taking that subset. But which subset you would choose? There should be some condition, right? To pick that particular people or sample. So whenever you are applying a unique condition on it to work upon the data is your sampling frame. So there should be some or the other way, some condition to be applied on the sampling frame so that every data point, right, each and every data point is considered as unique, right? When you observe that if you have every data point is unique, right, then only we can define probability. So that is done on sampling frame. So the condition what you apply on data, if I put it right, from such a big population, you are getting sampling frame. Putting a condition, you're just cut shorting you're like taking steps to get a sample. Right? So any example, friends? See, simple reason is that now a simple example is that here you have population, entire country's population. Entire country are there in the population. So how do I pick a sample here? To make this sample, what I do, I should apply, I can't go and ask everyone who is sitting at home, every door I can't knock and I'll ask them that, see, if I am conducting a survey, who would win the next PM, for example. I don't knock the door of everyone, right? I should just go ask what is your choice? Whom do you think? So what I do, and also when I want to conduct any exit poll survey, I should apply some condition and I should take only those people who have some knowledge about that. So what is the condition I take? People who are eligible to vote, right? Maybe that eligibility criteria here is taken into consideration. Maybe I say that voter ID is must. People who have voter ID or who have crossed 18 years of age, right, they would get filtered out, right? Then what happens here, friends? After you get from almost 120 crore, suppose, right, from that so many will get filtered when you apply this unique condition. And that's what is happening, right? The same procedure is even for COVID-19 vaccine also. If you relate it to that, entire country is waiting. Now you have to apply one condition here. Only few countries should be selected, right, where they try to take them and test the vaccine for the first time. So what conditions they apply? If you just know this, the clinical trials are, when they are performing these clinical trials, always the poor countries are targeted, friends, right? Because they'll be ready. Yeah, few countries would they would name, right? From those countries, they move on to the next step, right? Now, yes, sampling. What is the sampling here now? How many types of sampling are there? Yeah, we have applied some condition, we got the people who have voter ID and who have crossed their 18 years. Right now, what will we do? You have to apply some sampling methods here, right? What methods will apply here? How many types of sampling methods are there? SRS, only SRS, Kiran? Okay, let me put the question here. What are the sampling methods you can apply? Whatever you know, you just tell me. I'll make a note of it. What are the sampling methods here? Only two? Okay. Yeah, two, correct. Tell me. One is your two sampling, right? One is your biased and other is your unbiased. Probability and non-probability. Exactly. Yes. Yes, the same. Right? So what does this biased sampling means? So this bias sample is nothing but you are selecting people of your own choice. If I just ask how is the session, right? If I just pick randomly, I don't know you people, I just pick randomly and I do it, right? So that is called as blindfolded technique. I don't know anyone, I'm just blindly asking few people how was the session going on. But if I only ask few of you whom I know, right, whom I know, if I ask them what is that happening here, I would get a result, right? Everyone would say that yes, it's very good. So I know the people, I'm asking them whom I know. Selection and process is happening here. So this is called as biased sampling. Unbiased is called as blindfolded technique. So whatever you call it as your SRS, that is simple random sampling. Right? So the examples you can say, one of the examples of unbiased sampling is your, what you call it as simple random sampling. Okay. So if I just ask you people, right, I want to pick the winner from a pool of contestants, lottery type. So what happens there? What kind of sampling you would prefer now? Like what is happening? What kind of sampling is happening there? You're picking winners from a pool of contestants who have, you have to take one lottery out of it. And the guest has to take that. He or she is a person to choose that particular winner. Tell me, what kind of sampling is that? How would he choose? Definitely it is a blindfolded technique, right? It is a blindfolded technique where he'll just pick one because you don't know anyone. Right? Random sampling, blindfolded technique. He directly pick one from that particular big box. Right? So taking I can say that biased would be something like your movie reviews. Movie reviews are taken from the people who like that particular hero or, the cast and crew of that particular entire movie. Right? Like, when you talk about, if you differentiate the sampling methods, you have bias. Most used is SRS technique only, but it is good that if you know all other techniques also. Bias sampling, you have something like judgmental, you have snowball, right? And convenience sampling. When you talk about unbiased, as you told, it is simple random sampling, right? Or you make people some clusters, right? Or you can say that stratified sampling, right? Now can anyone tell me what is this judgmental sampling? Any example for that? Convenience or snowball? Because I've told you for SRS, right? What is this judgmental sampling method is? Or convenience or anyone? Snowball. So when you talk about judgmental, right, the name itself, you will understand that only on the basis of some knowledge, right, researchers knowledge, you would take the judgment to pick that particular sample because it is biased, right? He knows it. And whatever results you get when you go for this sampling, they are very, very accurate, with the margin of error is very, very minimum here when you talk about judgmental, right? So what happens here when you are picking your good, after doing so much of research, and you have very good knowledge and picking these, the results would, the approach, whatever you do, right, you would directly target that. So you can directly easily conduct one survey with that particular sample, because you have picked those people who have got appropriate knowledge here to give you the solutions or whatever is required for you, right? That is nothing but your judgmental. It is kind of biased. Now what is this snowball and convenience sampling about? Both are different. Convenience is the name, understand that it is conveniently available, right? So if I say that convenience, if suppose an NGO, right, that particular organization, right, they want to establish themselves in more 20 cities, right? What it will do, it selects 20 top cities, right, to serve on its own choice, right? Right, they know what proximity they are based to, right? Right, so this top 20 cities to serve based on the proximity to where they are based upon. So what happens here, it is very easy to do research, readily available sample data here. So convenience sample is a little bit low cost compared to others, right? Now let's talk about snowball sampling, right? So what is a snowball sampling about? If at all, for example, you want to know this customer satisfaction, right? You want to know about the customer satisfaction. Suppose you talk about any product, right, or any club or any institute or something, anything. So it would be extremely difficult for you to collect the data only there. Forget about the sample. To collect the data is only, it's very difficult to understand the customer satisfaction there. So what is the thing you have to do? Unless and until someone will help you, right, to provide the contact details or to give some information, you will not move forward. So if you are this, you just connect to one, again two. So if you have one here, two, again two, you improve to maybe four to prepare your sample. So it is increasing like a snowball, friends, size, right? It is increasing like a snowball. So, there's a kind of disadvantage here when it's snowball here. We can say that people whom you select, so this person, the first person would give the contact details of only the person whom he knows. Lack of cooperation may happen. Thus, whatever it is, like keenly biased situation would come, because the appropriate results would not appear here, friends. It's a disadvantage for snowball sampling. Why? Because whatever results you get, whatever data whatever the person is giving, you have to accept it and do. You don't know how worth it is. Right? It's very hard to find. Yes, exactly, Kiran. It's very hard to find. To get a good, content or the information, to do some, like a primary data source, very costly. Right? It's the primary data source, to collect it is very costly, right? It's a kind of source what you have to do. So we could cover in inferential statistics. We understood now what is this descriptive and inferential statistics. Any unique condition you are applying on the data, population data is sampling frame. You can apply any sampling method, right? Any sampling method to get your samples. It is biased or it is unbiased, right? It is of your choice now, but they are mostly it is preferred. What we understood that is SRS technique. That is a blindfolded technique, just closing our eyes and picking few people. Okay, now if you start off with, now we know the business moments, right friends? Now what do you understand by business moments? If I say business moments, what is the first thing comes? What is it all about? Party survey on election. Yeah. Okay, Rajkumar. Next. Yeah, friends. What is business moment? Moment means, divide that word into two. Inferential statistics we have divided. Descriptive statistics we have divided. Now divide that business and moments. What do you understand by business moments? Moments are nothing but, we say that they are truth, right? There's nothing but moments. So whatever management want to seek from the data, right, you call them as, and what they want to make businesses out of it, right? That is called as business moments. Description about our data. Truths, whatever are there. Insights, what you call. Other word, moment is nothing but the truth. The truths which are involved with the data, whatever you have collected. Right? Okay. Then why don't we enter into the first business moment? What does it capture, friends? You can explain me. Explain the first business moment decision. Yeah. First business moment decision. Sorry. Okay, mean, median, mode, measures of central tendency. Okay, one thing is correct, that is measures of central tendency, right? What are we doing here, friends? We are capturing the characteristics of the data. Exactly, Rajkumar, Kiran, Rakesh, right? You are capturing the characteristics of the data. Whatever you calculate here, that is your representative value, I can say, right? When you talk about mean is nothing but the representative value of your entire data. By looking at one single calculation here, you would get a lot of information here. That is called as average, right? So this mean will act like a balance here and there, right? Because of that mean only you'll understand. It's a balance, right? Yes, it's a measure of central tendency. So if I say that whatever salaries are offered to the students from uni post graduation, right, on an average only you calculate it. Is it correct? So out of that, if I talk, right? The salaries offered to students from a uni post graduation pass outs or whatever it is. From that, outliers are those people who get very high salaries. So because of that one or two outliers, just like if I say whoever are passing out from our institute, right, they are drawing a salary of 1 crore. What happens to this? This 1 crore is eye catching. But whenever you talk about this, why it is 1 crore? Maybe the people who passed out, right, from that particular graduation institute, only one or two have got that, right? Those are nothing but your outliers. So because of this one or two people, maybe they are very good, excellent, right? The overall representation of the data is affecting the figure of the salaries for the universities. So because of that outliers concept, we are moving to median, right? If at all you have categorical data, you have to calculate mode. So mode is nothing but the most repeated value here, right? So how do you explain mean? How do you calculate mean? Right? On an average, if I say that, if I would like to give you an example here. See, due to lockdown, every one of us gained weight, right? Husbands, right? They improved a lot, right? Maybe people have become 80 kgs just on jovial note, friends. So wife working at home, no maids, nothing. She lost weight here, right? But still, these two feel that they are maintaining a very good weight, absolute correct weight. Every day they feel happy. Why is that, friends? Any guesses? Why do they feel that yes, they are maintaining perfect weight? They say that on an average, it is how much? 130 by 2, right? It is 65 around, right? On an average, they are on perfect weight. That is how the concept of average would be, friends. So on an average, there would be some change occurring, but still, this particular 65 kgs is representing your entire data here. Whatever data you have it. Okay. Anyway, I have taken the concept of mean. Then I would like to ask you that which data point you can say that differs significantly from other observations. What is a data point called as? Any data point that differs, let me put it on the paper. What is that called as, friends? That differs from, I can say differs significantly from the other observations. I'll write it, right? Yeah. Yes, friends. Oh, Kiran already said, yes, it is an outlier, right? Your entire data would be here, right? 1, 2, 3, 4, 5, 6. One value, which is eye catchy, right? Some 500, 590 is here. So everything is this side. Others two values are away from your observations, right? That is nothing but your outliers, right? That is called as your outlier, right? Okay. Can we apply mode on continuous data, friends? Yeah. Can we apply mode? Yeah, tell me. Can you apply mode? No. Okay, next. Anyone else? Contradictions for no and yes? Okay. It is, I say that it is yes and no, both. So, why? Because, when I talk about mode for population, right? When we talk about mode calculation, right, it is for population. Then what happens if you just consider the data? The data is continuous. So for population data, you can't calculate mode because it is huge data, right? But of course, yes, when you take a subset of data, when you take sample, maybe there is a chance that if you have fixed data points, right? If you have fixed data points, then you can calculate mode on continuous data also, right? It is fixed data points. If you have, the answer would be yes if it is sample, no if it is population, right? No for the population. So next, when you talk about the first, then why don't we start with the second business moment, right? So tell me, what aspects does this second moment capture, friends? Second business moment, I can say decision, captures what? Measure of dispersion, spread of the data. Okay. What does it actually capture? Standard deviation. You are telling the components. Okay. Standard deviation and variance. Exactly. One more thing you're forgetting, friends. Standard deviation, variance. Yeah, exactly. Range. Right. Range is what is also important. So the second moment, business moment, it captures the average spread of the data, right? It talks about the average spread of the data, and from the center is what it captures, right? The average spread of the data from the center. So you have the data points around like this. So what you do here, from this center mu to this data point, how is the spread, right? So it's just like, you're manufacturing a product within some specified limits, right? So there's a limit. You have an upper boundary specific limit and lower specific limit, where this would help you. This is your mu. So within this, only your manufacturing of the product should happen. Otherwise, it says that this is not accepted, right? If the deviation is very huge, right? Very, very big, no, that is not acceptable, right? It's just like, within the specified limitation, if the product is manufactured, good. Otherwise, it would become like, men definitely, just like, when they try to prepare rotis, right? What happens? If they have a very good, if you compare it between a married and unmarried person, if they were asked to prepare rotis, what happens? There will be a lot of inconsistency, right? In the size of the rotis. One roti would be of this shape, one roti would be of this shape, one would be like our India map. provided if he's not chef, okay, that condition exists. So that inconsistency is what you capture in second business moment, right? Nowadays, even I agree that, girls are also unable to prepare perfect round shape rotis, but if I say men, it would be appropriate, right? So that's why. Okay, Rakesh is accepting, yes. Okay. Then, so we'll stop here. Okay, we would discuss more about the second, third, fourth, fifth, more and more topics. Not fifth, second, third, fourth business moments. Yes, exactly, Rajkumar. Country shapes would come. So that is nothing but your inconsistency that is not accepted. So it should be like this. The spread should be, within this. If you have drawn like this, every data point, like every roti should be same circle, right? Though you take same dough, the roti will of different shape. That is not accepted. So this is the range what you maintain, right? Here what happens? You have data points like this. A lot of the consistency is not maintained here. So that is what this captures. It talks about the spread of the data. And it talks about the spread. Okay, why don't we take one more question and stop here? What is this degrees of freedom then? We talked about, yes, like mean variance, right? We talked about standard deviation. We also know now this also is under your second business moment decision. Now, what is this degrees of freedom? Yeah. Okay, let me note it. Or I can say, what is n minus 1? Are the formulas same for sample and population, friends? Oh, very good. N minus 1 is correct. But what is this n minus 1? Very good. I agree. It is n minus 1. Okay. Yeah. Good that n minus 1. Is the formula same for sample and population, friends? Variance, standard deviation? Yeah. Any of the direction in which independent motion can occur. Okay. Any other? What is the notation here? When you talk about degrees of freedom, right, it basically talks about the choice we make, right? We have a choice of making it. So what is the freedom that we have to choose that particular desired data points, right? It will change from one business to other business requirement. So what we do, it is not just like n minus 1, it is actually n minus k. Right? We are trying to satisfy this condition of n minus k. So the value of the constant is what you are writing it as 1. Right? So based on the particular thing, you choose how many for how many data points you have the freedom to choose. Yeah, that is your degrees of freedom. So when you talk about the formula here, you have for sample standard deviation, the notation would be S, right? So when you talk about population parameters, you should always be So knowing the difference between sample statistics and population parameters. For mu, you have, sorry, you call it as mean for mu. For sample, you call it as X bar, right? Then when you talk about variance, standard deviation, sigma square, sorry, sigma square. Here it would be variance is S square, here it is S, right? So whenever you are working on sample, these are your sample statistics. So due to inferential statistics concept, whatever you are working with the sample, the variance you calculate on sample should be at least appropriately near to population. So statisticians, mathematicians, they have done research and they thought that if you just put n minus 1 instead of n in the formula, right? Right, what happens is that this n minus 1 will help to reach the variance of your population. Right, that is your degrees of freedom. So you have to remember this difference. Okay. So hope you could recap few things, few of the topics, right? Initial topics of our statistics, right? And good response from you guys. So thank you so much. We'll reconnect again same time next week. Okay. Thank you so much. Have a nice day. Good night.